The third section of the course will cover chapters 14 and 15. Chapter 14 is on database connectivity and web technologies. Databases are the central repository for critical data generated by business applications, including newer channels such as the web and mobile devices. For businesses to remain competitive, data must be readily available anywhere and anytime to all business users and in all types of formats such as desktop spreadsheets, Visual Basic applications, web front-end, and newer technologies such as smartphones and tablets use. So database connectivity refers to the mechanisms through which application programs connect and communicate with data repositories. Database connectivity software is also known as database middleware because it provides an interface between the application program and the database. The data repository, also known as the data source, represents the data management application such as Oracle SQL Server or IBM DBMS that will be used to store data generated by the application program. Alright, ideally, a data source or data repository could be located anywhere and hold any type of data. Alright, so the need for standard database connectivity interfaces cannot be overstated. Just as SQL has become the de facto data manipulation language, a standard database connectivity interface is necessary for enabling applications to connect to data repositories. Although there are many ways to achieve database connectivity, this section will cover the following interfaces: native SQL, Microsoft's Open Database Connectivity, data access objects and remote data objects, Microsoft's object linking and embedding for database, Microsoft's ActiveX data objects, and Sun's Java data connectivity. You should not be surprised to learn that most interfaces you are likely to encounter are Microsoft offerings. Client applications connect to databases, and the majority of those applications run on computers that are powered by some version of Microsoft Windows. The data connectivity interfaces illustrated here are dominant players in the market, and more importantly, they enjoy support of most data vendors. In fact, ODBC, OLEDB, and ADO.NET form the backbone of Microsoft's Universal Data Access Architecture, or UDA, which is a collection of technologies used to access any type of data source and manage the data through a common interface. Most DBMS vendors provide their own methods for connecting to their databases. Native SQL connectivity refers to the connection interface that is provided by the database vendor and is unique to that vendor. The best example of this type of native interface is Oracle Relational Database Management System. To connect a client application to an Oracle database, you must install and configure Oracle's SQLnet interface on the client computer. Native database connectivity interfaces are optimized for their DBMS, and those interfaces support access to most or all of the database features. However, maintaining multiple native interfaces for different databases can become a burden for the programmer. Therefore, the need for universal database connectivity arises. Usually, the native database connectivity interface provided by the vendor is not the only way to connect to a database. Most current database management systems support the database connectivity standards, most common being ODBC. Alright, so developed in the early 90s, Open Database Connectivity, or ODBC, is Microsoft's implementation of a superset of the SQL Access Group Call Level Interface, or CLI, which is standard for database access. ODBC is probably the most widely supported database connectivity interface. It allows any Windows application to access relational data sources using SQL via a standard application programming interface, or API. The Wikipedia Online Dictionary defines an API as a set of routines, protocols, and tools for building software applications. A good API makes it easy to develop a program by providing all the building blocks. The programmer puts the blocks together. Most operating systems, such as Windows, provide an API so that programmers can write applications consistent with the operating environment. Although APIs are designed for programmers, they are ultimately good for users because they guarantee that all programs using a common API will have similar interfaces. So that makes it easier for users to learn new programs. ODBC was the first widely adopted database middleware standard, and it enjoyed rapid adoption in Windows applications. As programming languages evolved, ODBC did not provide significant functionality beyond the ability to execute SQL to manipulate relational style data. Therefore, programmers needed a better way to access data, so they came up with Data Access Objects, or DAO. It's an object-oriented API used to access MS Access, MS Fox Pro, and DBase databases using the JET data engine from Visual Basic programs. DAO provides an optimized interface that exposes programmers to the functionality of the JET data engine on which MS Access is based. The DAO interface can also be used to access other relational style data sources. Remote data objects. Okay, that's about the DAO right there. Remote data objects, or RDO, is a higher level object-oriented application interface used to access remote database servers. RDO uses the lower level DAO and ODBC for direct access to databases. Is optimized to deal with server-based databases such as MS SQL Server, Oracle, and DB2. DAO and RDO object interfaces provide more functionality than ODBC. They make use of the underlying ODBC data services. ODBC, DAO, and RDO are implemented as shared code that is dynamically linked to the Windows operating environment through dynamic link libraries, or DLLs, which are stored as files with a .dll extension. Running as a DLL, the code speeds up and loads during runtime. This figure illustrates how a Windows application can use ODBC, DAO, and RDO to access local and remote relational database sources. So your database vendors provide ODBC database drivers to Windows applications so they can access their respective databases. The JET engine supports MS Access databases and other SQL-aware data sources. Then you have your data access objects and your remote data objects. Alright, ODBC architecture has three main components. You have a high-level ODBC API through which application programs access ODBC functionality. You have a driver manager that is in charge of managing all database connections, and you have an ODBC driver that communicates directly with the database management system. Defining data source is the first step in using ODBC. To define a data source, you must create a data source name, or a DSN. To create a DSN, you need to provide the following. The ODBC driver. You must identify the driver to use to connect to the data source. A name. This is a unique name by which the data source will be known to ODBC and therefore to the application. And then, excuse me, let me postpone this. And then you have the ODBC driver parameters. Most ODBC drivers require specific parameters to establish a connection to the database. And then here it shows configuring it. You have where you're defining your DSN and your drivers and all that. Here it shows the boxes that would come up to configure that. And then once ODBC data source is defined, application programmers can write to the API by issuing specific commands and providing the required parameters. And although ODBC, DAO, and RDO are used, they do not provide support for non-relational data. To answer that need and to simplify data connectivity, Microsoft developed Object Linking and Embedding for Database, or OLEDB. Based on Microsoft's Component Object Model, COM, OLEDB is database middleware that adds object-oriented functionality for access to relational and non-relational data. It was the first part of Microsoft's strategy to provide a unified object-oriented framework for the development of next-generation applications. It is composed of a series of COM objects that provide low-level database connectivity for applications. Because it is based on COM, the objects contain data and methods, also known as the interface. The model is better understood when you divide its functionality into two types of objects. You have consumers, they're objects that request and use data, and you have providers, which are objects that manage the connection with a data source and provide the data to consumers. Data providers provide data to other processes. Database vendors create data provider objects that expose the functionality of the underlying data source. Service providers provide additional functionality to consumers. The service provider is located between the data provider and the consumer. The service provider requests data from the data provider, transforms the data, and then provides the transformed data to the data consumer. As a common practice, many vendors provide OLEDB objects to augment their ODBC support, effectively creating a shared object layer on the top of their existing database connectivity through which applications can interact. OLEDB provides additional capabilities for applications to access data. However, it does not provide support for scripting languages, especially the ones used for web development, such as ASP and ActiveX. A script is written in a programming language that is not compiled but is interpreted and executed at runtime. To provide that support, Microsoft developed a new object framework called ActiveX Data Objects, or ADO, which provides a high-level application-oriented interface to interact with OLEDB, DAO, and RDO. ADO provides a unified interface to access data from any programming language that uses the underlying OLEDB objects. And this figure illustrates ADO and OLEDB architecture and how it interacts with ODBC and native connectivity options. So it shows here what interacts with what. Alright, ADO introduced a simpler object model that was composed of only a few interacting objects to provide the data manipulation services required by the application. There's an example of that in 14.2 in your book on 633. Connection, command, record set, and fields are sample ADO objects. Based on ADO, ADO.NET is the data access component of Microsoft's .NET application development framework. The Microsoft.NET framework is a component-based platform for developing distributed, heterogeneous, interoperable applications aimed at manipulating any type of data using any combination of network, operating system, and programming languages. To understand the importance of the new model, you should know that a data set is a disconnected, memory-resistant representation of the database. That is, the data set contains tables, columns, rows, relationships, and constraints. Once the data are read from a provider, they are placed in a memory-resident data set, which is then disconnected from the data provider. The data consumer application interacts with the data in the dataset object to make inserts, updates, and deletes in the dataset. Once the processing is done, the dataset data are synchronized with the data source and the changes are made permanent. The dataset is internally stored in XML format, and the data in the dataset can be made persistent as XML documents. This is critical in today's distributed environments. You can think of the dataset as an XML-based in-memory database that represents the persistent data stored in the data source. And here it shows the .NET framework. Alright, you have your connection, which often defines the data source used, the name of the server, the database, and so on. You have your command, which the command object represents a database command to be executed within a specified database connection. You have your data reader object is a specialized object that creates a read-only session with the database to retrieve data sequentially and very quickly. You have your data adapter. The data adapter object is in charge of managing a dataset object and is the most specialized object in the ADO.NET framework. It contains the following objects that aid in managing the data in the dataset, which is the select command, the insert command, the update command, and the delete command. You have your data set. The dataset object is the in-memory representation of the data in the database. You have your data table. The data table object represents the data in tabular format. You have your data column collection, which contains one or more column descriptions. Data row collection, which contains 0 rows, 1 row, or more than 1 row. And you have your constraint collection, which contains the definition of the constraints for the table. A data set is a simple database with tables, rows, and constraints. Alright, your Java is an object-oriented programming language developed by Sun Microsystems that runs on top of web browser software. Java is one of the most common programming languages for web development. Sun Microsystems created Java as a write-once, run-anywhere environment, which means that a programmer can write a Java application once and then run it in multiple environments without any modification. The cross-platform capabilities of Java are based on its portable architecture. When Java applications need to access data outside the Java runtime environment, they use predefined application programming interfaces. Java Database Connectivity, or JDBC, is an application programming interface that allows a Java program to interact with a wide range of data sources, including relational databases, tabular data sources, spreadsheets, and text files. The advantages. One is that JDBC is that it allows a company to leverage its existing investment in technology and personal training. It allows programmers to use their SQL skills to manipulate the data in the company's database. As a matter of fact, it allows direct access to a database server or access via database middleware. Furthermore, it provides a way to connect to databases through an ODBC driver. This shows the configuration. The database access architecture is very similar to ODBC, OLE, ADO.NET. All database access middleware share similar components and functionality. When it managed over other middleware is that it requires no configuration on the client side. The driver is automatically downloaded and installed as part of the Java applet download. Okay, millions of people all over the world access the internet and connect to databases via web browsers or data services. For example, you use your smartphone app to get weather information. Internet database connectivity opens the door to new innovative services such as they permit rapid responses to competitive pressure by bringing new services and products to market quickly. Increase customer satisfaction through the creation of web-based support services. Allow anywhere, anytime data access using mobile smart devices via the internet. Yield fast and effective information dissemination through universal access from across the street or across the globe. Given these advantages, many organizations rely on their IT departments to create universal data access architectures based on internet standards. Alright, so some characteristics and benefits of internet technologies. Hardware and software independence, saves in equipment and software acquisition, has the ability to run on most existing equipment, platform independence and portability, no need to have multiple platform development, common and simple user interface, reduced training time and cost, reduced end user support cost, no need for multiple platform development. Location independence, global access through internet infrastructure and mobile smartphone devices, reduced requirements for dedicated connections. Rapid development of manageable cost, availability of the multiple development tools, plug-and-play development tools, more interactive development, reduced development times, relatively inexpensive tools, free client access tools, low entry cost, frequent availability of free web servers, reduced cost of maintaining private networks, and distributed processing and scalability using multiple servers. Alright, so in general, the web server is the main hub through which all internet services are accessed. For example, when an end user uses a web browser to dynamically query a database, the client browser requests a web page from the web server. When the web server receives the page request, it looks for the page on the hard disk. When it finds the page, the end server sends it back to the client. Alright, so dynamic web pages are the heart of current websites. In the scenario that's presented in the online content, I believe, web server will generate the web page contents before it sends the page to the client web server, our web browser. The only problem with the scenario is that the web server must include the database query result on the page before it sends that page back to the client. Alright, so unfortunately neither the browser nor the server knows how to connect to read data from the database. So to support that type of request, the web server's capability must be extended so it can understand and process database requests. So a server-side extension is a program that interacts directly with the web server to handle specific types of requests. In the preceding database query example, the server-side extension program retrieves the data from the database and passes the retrieved data to the web server, which in turn sends the data to the client's browser for display. The server-side extension makes it possible to retrieve and present the query results, but more importantly, it provides its services to the web server in a way that is totally transparent to your client browser. In short, the server-side extension adds significant functionality to the web server and therefore to the internet. A database server-side extension program is also known as a web-to-database middleware. Okay, so let's look at this example. The client browser sends a page request to the browser. The web server retrieves and passes the request to the web to database middleware for processing. The web-to-database middleware reads, validates, and executes the script. The database server executes the query and passes the results back to the web-to-database middleware. The web-to-database middleware compiles the result set, dynamically generates an HTML formatted page that includes the data retrieved from the database and sends it to the web server. The web server returns the just created HTML page, which now includes the query result, to the client browser. The client browser displays the page on the local computer. Alright, so then we talk about extending web server functionality. It implies that the web server and the web-to-database middleware will properly communicate with each other. A web server interface defines a standard way to exchange messages with external programs. We have two well-defined web server interfaces: Common Gateway Interface, or CGI, and Application Programmer Interface, or API. The Common Gateway Interface uses script files that perform specific functions based on the client's parameters that are passed to the web server. The script file is a small program containing commands written in a programming language such as Perl, C#, or Visual Basic. The script's file contents can be used to connect to the database and to retrieve data from it using the parameters passed by the web server. Alright, the main disadvantage of this, of the CGI scripts, is that the script file is an external program that executes separately from each user request and therefore causes a resource bottleneck. An application programming interface, or API, is a new web server interface standard that is more efficient and faster than CGI. APIs are more efficient because they're implemented as shared code or a dynamic link library. That means the API is treated as part of the web server program that is dynamically invoked when needed. APIs are faster than CGI scripts because the code resides in memory, so there is no need to run an external program for each request. Instead, the same API serves all requests. Another advantage is that API can use a shared connection to the database instead of creating a new one every time, as what is the case with CGI scripts. Alright, the web browser is software such as Internet Explorer, Google Chrome, Apple Safari, or Mozilla Firefox that lets end users navigate the web from the client computer. Each time the end user clicks a hyperlink, the browser generates an HTTP GET page request that is sent to the designated web server using the TCP/IP Internet Protocol. The web browser's job is to interpret the HTML code that it retrieves from the web server and present the various page components in a standard formatted way. Unfortunately, the browser's interpretation and presentation capabilities are not sufficient to develop web-based applications. The web is a stateless system. At any given time, a web server does not know the state of any of the clients communicating with it. That is, there is no open communication line between the server and each client accessing it, which of course is practical in a World Wide Web. Instead, client and server computers interact in very short conversations that follow the request-reply model. Client-side extensions add functionality to the web browser. Although client-side extensions are available in various forms, the most common are plugins, Java and JavaScript, ActiveX, and VBScript. A plugin is an external application that is automatically invoked by the browser when needed. It is associated with a data object, generally using the file extension, to allow the web server to properly handle data that are not originally supported. JavaScript is a scripting language that allows web authors to design interactive sites. JavaScript code is embedded in the web page and executed after a specific event, such as a mouse click on an object or a page being loaded from the server to memory. ActiveX is Microsoft's alternative to Java. ActiveX is a specification for writing programs that run inside the Microsoft Client Browser, Internet Explorer. Because ActiveX is oriented toward Windows applications, it has low portability. It extends the web browser by adding controls to web pages, including drop-down list, a slider, a calendar, and a calculator. Those controls are downloaded from the web server when needed, so you can manipulate data inside the browser. ActiveX controls can be created in several programming languages such as C++, Visual Basic, which are the most common. Microsoft's .NET Framework allows for wider interoperability of ActiveX-based applications. Alright, and then VBScript is another Microsoft product that is used to extend browser functionality. It is derived from Microsoft Visual Basic. Like JavaScript, VBScript code is embedded inside an HTML page and is activated by triggering events such as clicking a link. A web application server is a middleware application that extends the functionality of web servers by linking them to a wide range of services such as databases, directory systems, and search engines. Web application servers can be used to perform the following: connect to and query a database from a page, present database data in a web page using various formats, create web pages to insert, update, and delete database data, create dynamic web search pages, enforce referential integrity in the application program logic, use simple and nested queries in programming logic to represent business rules. Web application servers provides features such as an integrated development environment with session management and support for persistent application variables, security and authentication of users through our IDs and passwords, computational languages to represent and store business logic in the application server, automatic generation of HTML pages integrated with Java, JavaScript, VBScript, ASP, and so on, performance and fault-tolerant features, database access with transaction management capabilities, access to multiple services such as file transfers, database connectivity, email, and directory services. Web database development deals with the process of interfacing databases with the web browser. In short, how to create web pages that access data in a database. This section presents two simple code examples, Cold Fusion and PHP. Because this is a database book, the examples focus only on commands used to interface with the database rather than the specifics of HTML code. So it runs through that example in your book, starting on page 645. It illustrates the web to database interface. And if you walk through the steps, it explains how to use Cold Fusion and PHP to create a simple web page to list the vendor rows from a database. I'm not going to walk through all of this with you. You're welcome to look through that on your own, that example, and if you've got questions, let me know. I'm going to move on and talk about XML, or Extensible Markup Language. It's a meta language used to represent and manipulate data elements. It's designed to facilitate the exchange of structured documents, such as orders and invoices, over the Internet. The World Wide Web Consortium, or W3C, published the first XML standard definition in 1998, setting the stage for giving XML the real-world appeal of being a true vendor-independent platform. Alright, so it allows the definition of new tags to describe data elements. It's case sensitive. It must be well formed, that is, the tags must be properly formatted. Most openings also have a corresponding closing. XML must be properly nested. You can use symbols to enter comments in the XML document. It shows those symbols there in next to the last bullet at the top on page 649. You have the less than, dash dash, and dash dash greater than symbols to wrap comments. The XML and XML prefixes are reserved for XML only. XML is not a new version or replacement of HTML. What it is concerned with is the description and representation of data rather than the way the data are displayed. It provides the semantics that facilitate the sharing, exchange, and manipulation of structured documents over organizational boundaries. XML and HTML perform complementary functions rather than overlapping functions. Alright, companies that use B2B transactions must have a way to understand and validate each other's tags. One way to accomplish that task is through the use of document type definitions, or DTDs. It's a file with a .dtd extension that describes XML elements. In effect, a DTD file provides the composition of the database's logical model and defines the syntax rules or valid elements for each type of XML document. An XML schema is an advanced data definition language that is used to describe the structure of XML data documents. This structure includes elements, data types, relationship types, ranges, and default values. An XML schema definition, or XSD, file uses a syntax that resembles XML documents. The code there at the top of page 653 in that figure 1417 is an example of an XML schema document. Alright. One of the main benefits of XML is that it separates data structure from its presentation and processing. By separating the two, you can present the same data in different ways, which is similar to having views in SQL. The Extensible Styles Language, or XSL specification, provides the mechanism to display XML data. XSL is used to define the rules by which XML data are formatted and displayed. Extensible Style Language Transformations describes a general mechanism that is used to extract and process data from one XML document and enable its transformation within another. And XSL style sheets defines the presentation rules applied to XML elements, somewhat like presentation templates. The XSL style sheet describes the formatting options to apply to XML elements when they are displayed on a browser, smartphone, tablet, and so on. Now that you have some idea what XML is, how do you use it, what kind of applications lend themselves particularly well to XML. So you have your B2B exchanges, which is XML enables the exchange of B2B data, providing the standard for all organizations that need to exchange data with partners, competitors, government, or customers. You have legacy system interaction. XML provides the glue to integrate legacy system data with modern e-commerce web systems. You have web page development. XML provides several features that make it a good fit for certain web development scenarios. Database support. A DBMS that supports XML exchanges can integrate with external systems such as the web, mobile data, and legacy systems, thus enabling the creation of new types of systems. These databases can import or export data in XML format or generate XML documents from SQL queries, while still storing the data using their native data model format. Database meta-dictionaries. XML is also used to create meta-dictionaries or vocabularies for entire industries. Examples of meta-dictionaries include HR XML for the human resource industry, the metadata encoding and transmission standard from the Library of Congress, the clinical accounting information data exchange standard for patient data exchange in electronic medical record systems, and the extensible business reporting language standard for exchanging business and financial information. XML databases. Most databases on the market support XML to manage data in some shape or form. XML services. Many companies are already working to develop a new breed of services based on XML and web technologies. Okay, so what exactly is cloud computing? According to the National Institute of Standards and Technology, cloud computing is a computing model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computer resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. The term cloud services is used in this book to refer to the services provided by cloud computing. Cloud services allow any organization to quickly and economically add information technology services such as applications, storage, servers, processing power, databases, and infrastructure to its IP portfolio. Cloud computing allows highly specialized IT-savvy organizations such as Amazon, Google, and Microsoft to build high-performance, fault-tolerant, flexible, and scalable IT services. Cloud computing is important for database technologies because it has the potential to become a game changer. Cloud computing eliminates financial and technological barriers so organizations can leverage database technologies in their business processes with minimal effort and cost. In fact, cloud services have the potential to turn basic IT services into commodity services such as electricity, gas, and water, and to enable a revolution that could change not only the way that companies do business, but the IT business itself. This is just a representation of cloud services on the web. Alright, so you have several implementation types. You have public cloud. This type of cloud infrastructure is built by a third-party organization to sell cloud services to the general public. The public cloud is the most common type of cloud implementation. It includes Amazon Web Services, Google Application Engine, and Microsoft Azure. You have a private cloud. This type of internal cloud is built by an organization for the sole purpose of servicing its own needs. Private clouds are often used by large, geographically dispersed organizations to add agility and flexibility to internal IT services. The cloud infrastructure could be managed by internal IT staff or an external third party. Community cloud, this type of cloud is built by and for a specific group or organization that share a common trade, such as agencies of the federal government, the military, or higher education. The cloud infrastructure could be managed by internal IT staff or an external third party. Characteristics of cloud services: ubiquitous access via internet technologies. All cloud services use internet and web technologies to provide, deliver, and manage the services they offer. The basic requirement is that the device has access to the internet. Shared infrastructure. The cloud service infrastructure is shared by multiple users. Sharing is made possible by web and virtualization technologies. Lower cost and variable pricing. The initial cost of using cloud services tend to be significantly lower than building on-premise IT infrastructures. Flexible and scalable services. The cloud services are built on an infrastructure that is highly scalable, fault-tolerant, and very reliable. Dynamic provisioning. The consumer can quickly provision any needed resources, including servers, processing, power, storage, and email by accessing the web management dashboard and then adding and removing services on demand. Service orientation. Cloud computing focuses on providing consumers with specific, well-defined services that use well-known interfaces. Managed operations. Cloud computing minimizes the need for extensive and expensive in-house IT staff. Types of cloud services. You have software as a service, or SaaS. The cloud service provider offers turnkey applications that run in the cloud. Consumers can run the provider's application internally in their organizations via the web or any mobile device. This consumer can customize certain aspects of the application but cannot make changes to the application itself. Platform as a service, or PaaS. The cloud service provider offers the capability to build and deploy consumer-created applications using the provider's cloud infrastructure. The consumer can build, deploy, and manage applications using the provider's cloud tools, languages, and interfaces. However, the consumer does not manage the underlying cloud infrastructure. Infrastructure as a service, or IaaS. In this case, the cloud service provider offers consumers the ability to provision their own resources on demand. These resources include storage, servers, databases, processing units, and even a complete virtualized desktop. The consumer then can add or remove the resources as needed. Alright, so advantages versus disadvantages. Of course, your advantages are low initial cost, scalability, support for mobile computing, ubiquitous access, high reliability and performance, fast provisioning, and managed infrastructure. Your disadvantages would be issues of security, privacy, and compliance, hidden cost of implementation and operation, data migration, complex licensing schemes, loss of ownership and control, organization culture, and difficult integration with IT systems. Alright, SQL data services. As you've seen in the chapter, data access technologies have evolved from simple ODBC data retrieval to advanced remote data processing using ADO.NET and XML. At the same time, companies are looking for ways to better manage ever-growing amounts of data while controlling costs without sacrificing data management features. Cloud computing provides a relatively stable and reliable platform for developing and deploying business services. Cloud vendors have expanded their business to offer SQL data services, or SDS, which refers to a cloud computing-based data management service that provides relational data storage, access, and management to companies of all sizes without the typically high cost of in-house hardware, software, infrastructure, and personnel. Alright, that concludes the lecture for Chapter 14. Look back over the material. Let me know if you have any questions.